Yes, dear students, class 11, gravitation chapter. I told you value of G on a surface in last video, and I told that this G equal to G me upon R square. So this is the value of G on a surface. Sorry, bachcho. So I told you that value of G on the surface is this. Then I told you effect variation D from on a surface. So one effect was shape of earth, another rotation. This topic here is effect of rotational motion on value of small g. You know what is small g? It is acceleration due to gravity. Now, shape of earth, I told you the actually earth is not exactly spherical. It is oval in shape and hence equatorial radius longer than polar radius. And due to that, effect value of G was maximum at poles and minimum at equator. Now, how this value be affected here? I am taking the earth to be spherical here. Earth has been assumed to be exactly spherical. And a body at point P, actually we live at different places on our surface. Here the body at point P, whose latitude angle is called latitude angle theta. So as Earth rotates about this axis with constant as omega, then the body here will rotate on this path. And you know, when body moves on circular path, that needs centripetal force. Centripetal force. Centripetal force. I have cleared this in my video on centripetal force. Why body needs centripetal force? When it moves on circular path, that needs centripetal force. Why? Because to move on circular path, direction of velocity keep on changing continuously. According to Newton's first law, the state of motion and state of rest cannot be changed without any force. Force is always required. When body moves circular path, direction is changing continuously. अभी velocity यहाँ फिर यहाँ ये फिर आई. So we can change direction of velocity by applying some force, and that force will be at right angle, and that is called central force. Now from where the body will need central force? Actually, the weight mg, I told you, if Earth supposed to be sphere and does not rotate, then value of this PC represent here mg. G is the accelerator is equal to ma. So it acts along PO direction. I have represented mg by PC. So a component of this mg weight will provide my central force towards PO dash radius. Component of this. So this mg can show a sum of this and this. This is value of this, so this will be mg dash. So value of g dash, value of g will change. So I am writing simply, let a particle of mass m is at point P on Earth's surface. Also let the latitude angle latitude angle b theta, latitude angle of point P is theta. You know, latitude lines parallel, circles parallel to equator are called latitudes. So this is equatorial latitude and this is the latitude of this place. If we join the two, we get this angle theta. As Earth rotates with angular speed, then the body at point P will also rotate on circular path whose center is O dash, and radius is equal to r, The body will need centripetal force. So centripetal force required by body equal to mr omega square act along PA. Now this force will be a component of mg. This force mr omega square will be a component of mg. So effective value of weight of body will be mg dash, which is along PB. Vector PB now represent effective weight, which is also equal to AC. Please don't get confused about centripetal force. This force is to be applied at right angle to velocity towards center. The body needs centripetal force. Some people have a confusion that centripetal force it itself produced when body moves on circular path because of centripetal acceleration. That acceleration has been defined there, centripetal acceleration. So that acceleration is produced by some external force and that force would act towards center. So that is centripetal force. Now there is a theorem of triangle. What is that? Please listen me. ABC. It is angle theta. So side opposite angle theta AC square is equal to AB square plus BC square minus 2BC. And back into BD होता है. But BD equal to AB cos theta. नहीं लिखा गया. एक थ्योरम है ट्रायंगल में. ये एंगल थीटा है एक्यूट एंगल. तो यह साइड पॉइंट टू एक्यूट एंगल AC स्क्वायर इक्वल टू AB स्क्वायर प्लस BC स्क्वायर माइनस ट्वाइस BC इंटू AB बी सी कोस थीटा होता है। तो वो मैं यहाँ लगाऊंगा इसमें। ये मेरा ये थीटा एग्जाम्पल ये है एम जी डैश। सो फ्रॉम फिगर एम जी डैश होल स्क्वायर इक्वल टू एम जी स्क्वायर प्लस एम जी स्क्वायर प्लस एम आर ओमेगा स्क्वायर होल स्क्वायर माइनस टू एम जी इंटू एम आर ओमेगा स्क्वायर कोस थीटा। From this m square here get cancel. So g dash square equal to g square plus r square omega 4 minus 2g r omega square cos theta. Since omega is very much less than 1, omega is the angular velocity of earth and that is 2 pi upon 24 r means 2 pi upon 80,400. Omega angular velocity of 2 pi upon t 2 into 3.14 1 day how many seconds 80,400. That way omega is very much so this term is negligible. So the term r square omega 4 is negligible. And hence g dash square equal to g square minus 2g r omega square cos theta. R is the radius of this path. This is radius of RE. From figure R equal to R cos theta. R is the radius of earth. So this g dash square equal to g square minus 2g r e omega square cos square theta. We have to find out g dash, not g square. So g dash equal to let me take g square common here. 1 minus 2 r e upon g into omega square cos square theta. And hence g dash equal to g 1 minus 2 r e omega square upon g cos square theta to the power half. Since omega is very small, omega square further small, so this term is smaller than 1. 1 plus x to power n equal to 1 plus nx. When x was less than 1. Binomial expansion. So we use that. So g into 1 minus half into 2r e omega square upon g cos square theta. This cancel. So we get g dash equal to g multiply करते हैं minus r e omega square cos square theta. Actually in books this relation is given directly. From where this relation has come to save the space. Actually now we have become exam oriented, not marks oriented. No, we should learn basic things. So now I come to this fact: g dash equal to g minus r e omega square cos square theta. Theta is the angle of latitude. Now number 1, if point P is on poles that theta 90. So g dash equal to g cos 90 0. तो g dash equal to g. So value of g does not change due to rotational motion nor due to shape of earth at poles. So at pole it is again maximum. Now number 2, if point P is on equator, then theta is equal to 0 degree, and hence g dash equal to g minus r e omega square. R is maximum at equator, so value of g again is least at equator. So both the factors, the shape of earth and rotational motion of earth, prove that velocity of value of g is minimum at equator and maximum at poles. And from data it has come out that variation of g on Earth's surface comes 65% due to rotational motion. And 35% due to shape. So this topic actually is not generally told by teachers in the class. They remain in hurry. I'm sorry to say, challenge here, लेकिन problem है. तो value of g यानी कि accelerated keep on changing on our surface. अभी when we go up तो भी change होगा. Though you are learning from class 9 that g is constant, it is constant up to certain height, but even it changes, that variation is negligible small. So there you can attempt a question. If a person moves from pole to equator, a question बना सकते हैं यहाँ. A person, if we move from pole to equator, then how much change will be in value of g? Value of g. Now it is due to rotational motion, due to rotational motion. So this change you will find where is the at equator the g dash equal to g minus r e omega square, and g the value of g here at poles. So g minus g dash equal to r e omega square is the difference. 6.4 10 to the power 6 is the radius of earth. Omega 2 pi upon 86,400. 86,400 square. So you will find the, you calculate yourself and match the answer from somewhere given data. It is given in NCERT book also. You can solve it, this will change because this value is very large, 8.6 10 to the power 4 ले सकते हैं, उसका स्क्वायर 8, तो 0.0 something आएगा change, but change is there. Although it is negligible small, but it is there because of shape of earth and rotational motion of earth. We will meet in next video. Thank you.